Alright, what's good, everyone? So as some people might know, probably not most people, but there's a competition called the Canadian Computing Competition, also by Waterloo, CCC, right? And takes place, I think, February, sometime in February, in like 2 weeks. And for the past year since the last CCC, I've not been doing many competitive programming questions. I've been doing too much web development, I won't lie. So in these next 2 weeks, I'll probably be practicing a lot of previous CCC problems. I just decided to just make videos, I guess, just record it. So yeah, that's why I'm mostly gonna be having the CCC problems for the next few videos. I don't know, but still, I'm just get started, I guess, right now. So I guess right now in the next hour or something, hoping to get done the S1 senior one for CC 2022, which was last year. Try to get done maybe S1, S2, and I'll see if I can get S3. I'll see if I have time. Well, let's just start it right now. And also, for some reason, probably for a good reason, in CC you can't have any boilerplate code or whatever starter. So I have to write this out by hand in the contest. So I guess we practicing this as well. So should I doing? All right. So this is S1, which is good 4s and good 5s. And I have done this only S1 before, and I had some crazy complicated solution, but I was thinking about this question and thought of a really simple solution that I'm gonna try to write out here. So let's just read out the question. So Finn loves 4s and 5s. In fact, he loves them so much he wants to know the number of ways a number can be formed using a sum of 4s and 5s. The order doesn't matter, and example is Finn wants to form the number 14. There's only one way to do this, which is 4 plus 5 plus 5. And if you want to form 20, there can be 2 ways. There can be 4 plus 4 plus 4 plus 4s. And you can also do 5 plus 5 plus 5 plus 5. And the final example, say to form the number 40, you can do it 3 different ways. Do all 4s, or 3 different, all 4s, all 5s, or you can have 5 4s and then 4 5s. So we have to determine the number of ways a number can be written as a sum of 4 and 5s. So input, let's say n. There's only one line containing n and other things. And we have to output the number of unordered sums of 4s and 5s that should form this number. And output 0 if there's no sums. So I think we're going to need an answer equals 0. And the really simple solution I was thinking of is just checking if n is the number is divisible by 4, or obviously minus, so we have another variable called I, and if I times 5 is divisible by 4, we increase answer and we just increase I. And as all this does is it checks if we have 1 5 And then of course 5 and 4 here, I guess would be interchangeable, work the same, but you start off with one of these, either 4s or 5s, being 0 of them, and then saying, can we make the number with only 1 5? Let me see, check if you make it with 2 5s, 3 5s, 4 5s. And then you should never get any repeats, and should be O of n. So we just see. And we can do while n is greater or equal to I times 5. And let me just check if this works. So I have 14. I have to output answer. 14 we get 2, which is wrong. Let me just check the code. If n minus, because we're using this many 5s, as that is divisible by 5 equals 0. Actually, mod 4 equals 0, just checks. It's divisible. I get 1. If I do 40, we get 3. And 6 we get 0. So let's assume this works. And let me just submit this over. Alright, that works. So let's move on to S2. Okay. Let's just copy this over. Oh, and I should probably have this on. Yeah. Alright, so S2 is good groups. So class has been divided into groups of 3. This division into groups might violate 2 types of constraints. Some students must work together in the same group, and some students must work together in separate groups. And we have to determine how many constraints are violated. So the first line will be X, and the next X lines will contain 2 different names, and these 2 students must be in the same group. Next line is another integer, and then the rule is again same thing, except the 2 students must not be in the same group. And each pair of students appears at most once. Okay. Next line will be an integer G, which have 3 different names, and these 3 students has been placed in the same group. Okay. So you have the rules, and then you'll have the actual groups, and we have to output, I guess, how many constraints are violated. Okay. So let's just try the input. Let's see. So say like n not same, then number of same. We have rules for same and not same. I'll use thinking of an unordered map. So not same. So we want to store all the rules about not same and then same. So I guess this would be an unordered set. So obviously we have the name and then an unordered set of students that can't be with, and then we'll have the same thing for same, and we'll just say temporary like name. I'll say CN name, and we'll say not same dot insert. I make pair name at yes name 2. Oh wait, can't do this. I have to check if this already has a name. If we already have name, then we'll just say name dot insert into, or else I think we can just do this, right? Because it should, if we use this, it should just create the pair if it doesn't exist, right? So okay, I think we can, obviously we have to do the same thing other way around, and we're going to do the same thing for the same, and then the next line will contain different groups. This one will be name 3. Okay. Should I name this just num m or n groups? For loop. Name 1, name 2, and name 3. Alright, let's see. So we have to have an answer. Should say equals 0. And let's see, how do we check for violations? Okay, that's violation. Okay. All right. So we can check if not same. Let's say name 1 dot. So if it contains name 2. If name 2 used to Rust, having not needing these parentheses on the side, this statement. Okay. So if we count this, let's say answer increases. Same thing with name 3. So it increases. And I guess we'll have this. It's not the nicest code. We'll have it work like this as well. And number 3, we'll check if it contains one and 2. And so that's for not the same. But how do we check if it's the same name 1? If they don't find well, let's think about this. We check the same. instead of, let's say, instead of this being unordered, so can I make this a vector? And we can just loop through let's say same of name 1, and if name 2 is not equal to the same name, and name 3 is not equal to the same name, then answer increases. And we can have the same thing, but this is the worst code I've ever seen. But do the same thing for 3 and here. I think there is a problem here because since we push back like this, if we match everyone with this, it'll violate the rule twice, and it should only be violated once. So I get so let's just see. Let's just have a temp, and let's say t. Let me just and divide by 2, and let's try putting answer. Alright, we're back. Okay, so I tried the sample. The output should be 0, and I got 1. Just think about this. The only violation is and this is not even a name, I swear. These two people shouldn't be together. And wait, is the first one must be in the same group? Did I just mess up the? I just messed up the order. All right, so let's move this here. And I didn't even see the output. I got 0. All right. And let's try this. It's 0 again, but it should be 3. Okay. So let's see the rules of this. So the first constraint is A and B must be in the same, and this is violated. So let's see what is done here. So the same name, same one. Let me just make sure that the same and not same are actually. It's actually what. Let me just print out the size. Let's just make sure these are actually being put in. Yes, it's not. Let me see. So if we get input for same name, let's say same, and one dot push back name 2. What if same dot counts? Say if this doesn't exist, we say dot insert same. Let's see, insert a. Let's do this. Name 1 and then a just a vector. Oh wait, it does work. Hold on. It's because this makes our output a bit non-trolling. Okay, so the size 0, 1, and so it doesn't work. Zero, 1, and 0 doesn't seem right. I don't know why this wouldn't work. Just make sure I'm looking at the right thing. 0. Same amount size is 0. Which does not count. Name 1, insert. Let's just insert something. So this works. This works. If let's say a size is 3. Oh. I have to do this. Okay. I said that wrong. Oh my gosh. Okay. So I don't need this, right? This should just work. Alright. So answer value is 5. Output is 3. Should I do the same thing here as well, where if it's the same, if it's in the same group, okay, this can also get violated twice. So how about I just divide it all by 2. I get 3. And this one at the start, I think still get 0. Okay. Make sure I don't have any other C out. Okay. So really, I can just try submitting this code. Okay. All right. Oh, so that's S2 done. Let's do S3. Oh, I'll just write it off. Just by hand. Let's see what. Let's say it's a practice thing. Let's see S4 real quick. Let's see S4 really quickly. I don't know why S3 is just. Maybe I'll get back to S3. Let me just try S4. Because S3 this doesn't seem too helpful. So Andrew is a very curious student who drew a circle 0, 0. Integer circumference that's greater or equal to 3. And the location of a point on the circle is the counterclockwise arc length from the rightmost point of the circle. So the 0, 1, 2. So it's the distance you go like this. So from the right. Okay. Andrew drew n greater than 3 points at integer locations. The ith point is drawn at Pi, and this just means it's somewhere along the circumference, and you can do multiple points at the same location. A good triplet. I'm guessing we need to find how many good triplets there are. Yeah. Distinct as well. Distinct. Okay, so a good triplet is defined as a triplet ABC that satisfies the following condition. A is alright, so they're strictly increasing, and they are smallest is greater or equal to 0 to 1, biggest or less or equal to n. The origin 0 lies strictly inside the triangle with vertices, the points at ABC, and the origin is not on the triangle's perimeter. And two triplets here and whatever are distinct if they're all not equal to each other. Okay. So I want to find the number of distinct good triplets. And the first line contains, I think this might be doable. It's a bit of some interesting math. Probably don't know how to do. Let's see. N and C. And the second line contains n spaced integers and integers. So n is the number of stuff, and then c is the circumference. C4 is I equals. So let's see the whatever marks, and we have to output an answer. I have a feeling we need a set, and let's see. So we have to put the points, and I think the points. I don't think the points really matter if there's multiple, right? Because if there's multiple points, obviously you can't have 2 points of a triangle at the same place. So let's just have it. How large can... Let's have an unordered set of ints, which we'll call points. So let's have a t and points dot insert t. Right, so we have all the points there, and the circumference. This might be difficult. Let's just try That'd be really bad having n. Well, maybe you can get these 3 marks at least. These are pretty difficult. Time is 3 seconds. Let's do a triple. That's it for loop. Oh no. Yeah, no. No. Well, let's just try this. So let's do this by answer. Answer here is 6, and you can see that here is 1. So for each one, let's say P1, P2, we check this, it doesn't work. 1 works, this doesn't work. So we can move on to the next. None of these work. 1, 2, and this one doesn't work, of course. 3, none of these work. 4 doesn't work. 5 doesn't work. 6, where's the 6? So 1, 2, 5. Of course, this one works. 1, 2, 3. Oh, you can have the same. Same thing works twice. We can assume if points dot say counts t say it doesn't exist t with 1 else let's say points t and then we just increase. So we can have the same thing twice, we just have it multiple times. All right, that's free. So let's see. So 1, 2, and 3. So this point repeats. 4. Which ones? 2, 5. Oh, 6, 7. Oh. Or 5, 6. 5, 6. Surely with some like math you can figure it out. So let's think about it. 2 points. You have 2 points, 1 and 2. So let's say the points A, B, C. A and B. The difference between A and B, let's say 4 and like 0 and 4, has to be less than the circumference, than half the circumference of the circle. Because if it's half the circumference, like 0 and 5, circumference here is 10. 0 and 5, the difference, obviously 5, it's going to be half. Right? And then the third point, it can just be any amount of points that is, what's here. But also it can't be too close. Because if it's too close, it'll avoid it the other way. That's tough. That's tough. So let's say we found a good point. Let's say 0 and 4. Now the difference between this point and the third point. Oh, this point and the third point. we'll have to. Okay. Let's see, answer plus equals. I don't know, points. Well, let's figure out what counts as a good triangle. So, I say the point 1, which is I. Should this be an unordered map? Unordered is kind of crazy. So if if is this legal? Is this legal? Or I guess we can have a. This might be memory inefficient. I don't care. Points back. This is so bad. Let's sort this. Points vector begin. Oh, or we can just as about the same. This is about the same. So dots on that. And up. Is this legal? Begin. Dots. How do you find the first one? Or can you just... I'm having a tough time with C++. This is not okay. But if... Let's say A, B, C. Right? If A or B minus A, as B will always be larger, right? Is greater or equal to C divided by 2. Then we say, let's say break. And over here, we'll have if C divided by, oh, C is it's a bad name, I already have C. And half C. Let's say that's 0.5. Let's just divide by 2, whatever. Half C, and half C. So yeah, if A, this is greater, half C, we break because if we're gonna have an ordered map, say strictly increasing, and if we're increasing, then my trip, wait, yeah, we don't want it to be greater. Because let's say we were at 0 and 5, or 0 and 4. 0 and 5, this is okay. 0 and 5 is not okay. So obviously 0 and 6 will never work, right? Because the second point has to be somewhere here. Okay, so we're good. But how do we get the ABC? So points dot size. Can we index a? We can't index a map, right? Can we index a map? There's some way of, let's say this equals points dot at I. Hoping that's how it works. Is this? Let me see if, say we had another, I don't think this is how it works. Let's say we have another map test at, okay, no, this is not how it works. Begin dot begin +1 auto, let's say a iter equals begin and a iter dot a iter dot, or let's say plus plus. Yeah, we advanced the iter here. Okay, so this seems alright. So a iterator b equals say b iterator b iterator equals 20 begin. Automatically we or a iterator, but then say b iterator. There's always one larger than a iterator. Oh no, I get it. This will be here, and then the C iterator will be B, and then C iterator plus Y. Okay, this is the worst thing I've seen. B is equal to B iterator dot first. It's not mentioned C yet. Okay, so let me rename this circumference. Okay. B iterator equals A iterator B plus plus, or yeah, because every time we need to start. Oh, it's a triple nested for loop. This is not good. We check. I mean, it should be alright. because when we do this, we go in B iterator plus C iterator plus here at the end of each for loop. We'll say if, then that's great. C is equal to break. But then if it works, we gotta check. So boom, 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 less than half. I think it should be good. So if it reaches here, answer plus equals. Let's just say 1 for now. I do have to worry about the multiple point thing. Well, let me just check if this works. I really hope this works. I at least have some. Oh my lord. Okay. Insert this. Points plus plus. This equals points at begin. Do I do it like this? I don't think it's good. Oh, whoa, whoa, whoa. Oh my, I actually got 6. Hold up. Let me just try running out, C outs. Say A, B, C, and L. So 0. 0, is this even 0, 2, and 5? This should work. 0, 1, and 5, yeah. Zero, 2, and 6. 0, 2. Wait. Oh, 0, 2, and 5 shouldn't work. Oh, we also have to find that this, the difference between this is greater. Or so 1, okay, so or if C minus A is less or equal of C. I see, because this has to be greater. So A and C, the difference between A and C, but the other way around. So A, so let's say circumference minus C minus A. So it'd be 10. Oh, is greater or equal. Alright, so we get 4. Which is what? Hold on. Which is 2, 5, and 6. So 2, 5, and 6, which should not work at all. I think I did this wrong. It is C. The difference between A and B has to be less. This has to be less, but A and C has to be more than half of the circumference. So, or if the difference between A and C is less or equal to half the circumference, like this, that doesn't count. So we break. We only get one result. Let's see. 2, 6, 9. 2, 6, and 9, which this works. But why doesn't something like, let's see, boom, boom, here. So 0, 2, 6. Why doesn't 0, 2, 6 work? Well, this should be good, right? I mean, it should work. Completely bewildered. Unlucky. I mean, this should well, I don't see what's wrong with this. Why shouldn't 0, 2, 6 work? Difference between 0 and 2, right, is not greater than half C. Difference between 2 and 6 is not greater than half C. Do we check that? Here we check B and A. Here we check C and B. And here we check C and A. And C and A obviously is 0 and 6, and 6 minus 0 is 6. 6 is not less than 5. So why doesn't it work? Okay, let's try getting rid of these, and let's see what happens with the like the total amount of combinations. So 0, 2, 5, 0, 2, 6. So it does happen. Should I continue? Start break. This might be it's slower again. Even if I continue, let's say would break. It would break here at 0, 2, 5. Oh, it would. because 0 to 5, yeah, this is bad. Oh, if that is true, we break. Continue. So this is okay. We got 4 now. And what are we missing? So we got 0, 5, 6, which I should really, to make it more readable, we can put I plus 1, J plus 1, so we can see like the J plus 1. Okay, so we got 1, 2, 3. No 3. Am I like? I'll just read it like this. Okay. So 0, 5, 6, which is 0. This should not work because it would break. Would break. Let's see if we actually see if we continue here. What happens? Again, we only have this. So if C plus B is greater than half C, the only thing will increase is C. So C will increase. If C is already too large, it will never get good enough. So it's good. This, if C gets larger, it's better. So this is continue, this is break. Alright, that's fine. C minus 2 is less than. Oh, we have to do this either way. I guess we shouldn't advance it at the end. Okay, so B equals, so as soon as you get it, just advance it, I guess. Where do we get the A? Get the A here. Okay, so what happens now if I actually continue and break? So we got 6, which is not good because we haven't implemented the other thing. It still works. Boom, boom, boom. Let's see if we bring this back. Do we continue? Continue just to be safe, or no? We break. We break. So we got 3. Which let's see. 0 to 6, 0 to 6, so that's good. 2, 5, 9, 2, 5, 9, okay, and 2, 6, 9, 2, 6, 9, that's good. So of course, I have to implement this triggering twice, the 2 thing, and the other thing triggering 3 times. So I think it should work as soon as we get this implemented. So it's, instead of answer plus equals 1, okay, 1, or let's say Oh, that actually makes it difficult. Let's store this. Okay. And let's just, what am I doing? Say plus equals Cn times, it's just An times Cn times Bn, right? And I get 6. So if I delete all this, we got 6. Oh, let's see. How this is super inefficient. I want to see if it. I just see if it works. Please, no. For clip, whatever. Output clip was 0. So I'm not forgiving enough. Maybe if I do this. And this will just make it worse, but maybe we get some answers right. It's still wrong. Because if we this doesn't make everything continue. Let's see if this works. Again, it doesn't work. Alright, so it's a new day. I'm revisiting this question, and you can see that I have gotten some of the right answers. And if you look at the code, I slightly changed it just so the for loops is just include the iterator. But other than that, it's about the same. And I did want to try something, which is, of course, replacing these with break. And of course you can see that sometimes you get a wrong answer, probably because again, the output is just too large. Something happened here. Probably, yeah, just output. The answer is too large, or of course time limit exceeded. But I'll try to resubmit this with these being break instead of continue. And the what I found, the reason why this didn't work before is because this half of the circumference, which I was using to figure out if 2 points could create a triangle at a third point. This half C was an int before, and that made it so if the circumference divided by 2 is, or if the circumference was odd, then if we divide by 2, it just rounds down if we have it be an integer. And that was why it wasn't working before. So I'm gonna try submitting this. And alright, okay. So again, it's the same result where first batch is fine. She somehow is wrong answer, and then still time limit exceeded. So I'm gonna try to see the constraints for batch 2. So The only, I guess, constraints for second batch is that the number of points can be much larger. Let me just see this. Which 2 didn't work. Yeah, so I guess that'll be a problem, and I am saying UN 64. Maybe this A points. I'll just try making everything UN 64. Let's just this probably won't work, but it's worth a try. Okay. Alright. Yeah, so with a 64 balanced integer, that should be enough, but again, the solution I wrote was just too slow, which is just unfortunate. I was thinking of a way to make this faster. Instead of 3 nested for loops, I would just be 2. But I think that's, maybe I'll try to figure out how to do that some other time. Yeah, I've been working on this problem for way too long. I think I'm gonna call it there. Alright. So I guess that's it for this video. Practice. Then there are some very difficult questions, especially S3. Which I really, I think S3 is just so much harder than S2. Alright, I guess that's it.